Good afternoon to one and all watching here. Today I'm going to teach the problems on the thermodynamics on the closed system. Okay, so let us see the first problem. So myself, Dr. Murugan, Associate Professor, working as Associate Professor in the Department of Mechanical Engineering in Kumku Engineering College. And let us have the first problem, that is zero point 0.5 kg of air is compressed reversibly and adiabatically from 80 kilopascal, 60 degrees Celsius to zero point 0.4 megapascal, and it is then expanded at constant pressure to the original volume. Sketch these processes on the PV plane and the TS plane. Compute the total heat transfer and the work transfer for the whole path. So actually this is the problem. So this is the problem that we are going to work it out. Okay. So first of all, whenever the problem is given on thermodynamics, we have to read the question twice. First thing, we have to understand the concepts and what are the data given in the questions. So in this given data, we have to identify what are the data given. What are the data given? That is zero point 0.5 kg of air is given. Initial pressure is given. Initial temperature is given, and the final pressure is given. So the given data are these, and from this given data we have to find out the total heat transfer as well as the work done for this process. Also we need to find out the we have to sketch the process on the PV and the TS planes. First let us draw the PV and TS plane. So this is the typical process. Okay. Okay. And 1, 2, and 3. So the process 1 and 2 is said to be, this is the PV diagram. Okay. And this indicates PV power gamma is equal to C. Okay. So this indicates the reversible and adiabatic process. This is the PV diagram. Now we have to draw the TS diagram. What it indicates? It is at constant pressure, constant entropy, and see here the process 2 to 3 is expanding, and okay. So this is the process of the TS diagram. Process 1, 2, 3. Okay. In this line, we can see that this is the V equal to C, and this is the line where V is equal to C. So this is the entropy line. This is the temperature line. So next we have to write the given data. Okay. So the given data indicates M is equal to 0.5 kg. P1 is 80 kilopascal. T1 60 degrees Celsius, and P2 is 0.4 megapascal. Okay. So with this, we have to find out the other remaining data given. Okay. We have to find Q as well as the W for the process. Now let us start. We know that V1 is equal to mR Okay. Then in the given problem, volume is not given. Okay. So we have to find out the volume by the relation, that is mR T1 by B1. So after giving this, we have to find out the mass, the initial mass, that is 1 into 0.287 into 333 to 2 into 80. Okay, here 1 by 2, that is zero point 0.5 they have given. Okay, and the final volume answer is 0.597 meter cube. Okay, then next process 1 to 2 is reversible and adiabatic. Okay, from this relation, that is T2 by T1 is equal to P2 by P1 power gamma minus 1 by gamma. Is it not? Then from this relation, we have to find out this T2. The initial temperature is given. Okay. Now we can write it as 400 divided by 80. We can assume the value for gamma as 1.4 and into. After calculating all this data, the T2 answer is 527 Kelvin. Okay. Now, now the next process is for process 1 to 2. The work done is given by the formula W1 to 2 is given by V1 V1 minus V2 V2 divided by gamma minus 1, or else we can write it as mR T1 minus T2 divided by gamma minus 1. Now we are substituting all the datas here, and now that is zero point 0.5 into 0.287 into 333 minus 527 divided by 1.4 minus 1. So after evaluating all this data, the answers will be minus 69.6 kilojoule. Okay. Then for the relation P1 V1 power gamma is equal to P2 V2 power gamma. Okay. Initially we have found out the initial volume. For this, we have to find out the final volume, that is V2 we have to find out by this relations. That is V2 by V1 power gamma is equal to P1 by P2. That is equal to 80 divided by 400. That is 1 by 5. Okay. Now we are substituting, that is V2 by V1 power gamma is equal to 1 by 5. Okay. 1 by 5. Now this relation, now this relation is expanded by V2 by V1. V2 by V1 is given by the relation, that is 1 by 5 power 1 by 1.4. That is equal to 1 divided by 3.0. 162. That is V2 divided by V1. Okay, and now we know that that is V2 is equal to 0.597 divided by 3.162. So the final volume is 0.189 meter cube. Okay, that thing we have found out. Then for the another process 2 to 3. Okay, work done for the process 2 to 3 is given by P2 of V1 minus V2. That is given by the expression 400 into 0.597 minus 0.189. So the work done is given by the answer 163.2 kilojoule. So in order to find out the total work done for the process, we have to add process 1 to 2 and work done for the process 2 to 3. So the answer is for process 1 to 2, we have 69.6 plus 163.2. So that is 93.6 kilojoule. Okay. Now we have to find out the total heat transfer for the process. So that is also given by P2 V2 divided by T2 is equal to P3 V3 divided by this T3. So for this T3 can be equated like this, that is T3 by T2 into V3 by V2. Okay, so that is answer is 527 into 3.162. 3.162. So that to find out the total work done, process 2 to 3 is given by MCP of T3 minus that is 0.5 into 1.005 into 1667 minus 527.85 kilojoule. So regarding the total heat transfer for the process, that is Q total is given by the process 1 to 2 plus process 2 to 3. Okay, here it is 0 and here the answer is 527.85. So the heat transfer for the total process is 527.85 kilojoule. Okay, so this is the final answer. Okay, this is the problem that we have seen in the closed system. Okay, so thank you for your patient listening. Thank you.